So welcome all to this in Sci'versation. This is 15th in series ever since we started this, 4 months ago. And today we have a wonderful guest in the form of Asif Khan, who is the president of Asia Pacific Bioinformatics Network and an associate professor at School of Data Sciences at Perdana University. He has also been associated with Turkish University as a visiting professor over the last 6 months. And he has recently been the convener and organizer of International Conference on Bioinformatics, which was held a couple of weeks ago. So before we introduce Asif further, I would probably request Asif to come up with his presentation, and then we'll have a quick Q&A Sci'versation where Asif would also talk about the kind of the education programs that he has been associated with, along with the research navigations, and also the kind of what AP Bionet has really been doing in the Asia Pacific regions in bringing the competence to the fore. So thank you so much, Asif, for the wonderful time and energy that you have bestowed today. We would like to hear from you, and please go ahead by sharing the screen and starting the presentation. Thank you so much. Yeah, hello, Asif. Are you around? If invariably has some connection problems, so I appreciate your patience. 1 minute, please. Yeah. I think Asif is just joining. Please let's wait for 1 or 2 minutes, please. I'm really sorry. I think he has got some connection problems. Yeah. Yeah, Asif has just given me a message that his computer has crashed, but he's working on some other stuff. I appreciate your patience, please. Huh? Yeah, thank you. Yeah, and I'm sorry, for keeping you waited. Asif is joining up, please. So in the meantime, a few of you can unmute and discuss, how good these civilizations are. Has it been helpful? Yeah.
Certainly, Prashant, it's really helpful because you're coming to know about how things are happening. Can you hear me?
Yeah. Thank you. Thank you so much, Anil. For this. I think we look forward to have you and Hima next week, Anil. So it's you both. Yeah. Thank you.
Like after listening to especially Banu Prakash sir, Rajiv, and followed by Professor Kavkishore sir, we came to know different things, how the hurdles they had faced in their research time and how they are keeping that thing going on. I mean,
Right.
most of the time we get disheartened something if we don't get in that particular moment. But by looking at them, I understood that okay, we need to keep on trying till we achieve that one.
Right.
I think Asif has joined now. Better
Yeah.
we'll start that one.
Yeah.
Yeah, thank you.
Yeah. Thank you, Anil. Yeah. So Asif, thank you again, for joining in amid your busy time. I think you're joining through mobile phone. If you can just share your presentation, maybe I can play it from here. Yeah, I think Asif has got some connection problems. I don't know. Yeah, Asif, can you hear me, please? Yeah.
Prash, can you hear me?
Yes, Asif. Thank you so much. Yeah.
Okay.
Yeah. So I'm so sorry for this chaos, Asif. That you're going through. Yeah. So I hope this is clear now. Yeah.
Yeah, it seems to be finally working. I don't know what happened, but
Yeah.
I hope this is it. Okay.
So while I was introducing you, I
Apologies
think
for the
this
chaos.
connection problem has happened, Asif. So I'll just have a quick introduction, about you.
Sure.
Yeah.
Sure.
So I take a great pleasure in having Asif M. Khan, who is the president of Asia Pacific Bioinformatics Network and an associate professor and dean of School of Data Sciences at Perdana University, Malaysia. He's also as a visiting professor in Turkish University. Besides which, he has marvelously worked on various facets of bioinformatics towards epitope-based vaccine delivery with Professor Shobha Ranganathan, as Professor Tantin V. And he had a brief stint of postdoctoral years of experience in Singapore and Australia, and before he taking up the current position at Perdana University. Over the last 2 years, he has been inducted as the president of Asia Pacific Bioinformatics Network, and he is spearheading a group of 16 executive committee members from 14 different countries in the Asia Pacific regions. And Asif has been instrumental in bringing up some educational-based programs through AP Bionet and as well as DS6 talks through Perdana University as well. And his interest has been towards bringing or bridging the gap between the bioinformaticists and biologists. And he has really been a big support for Bioclues family as well. Thank you so much, Asif, with this short, quick introduction again. This is over to you. You may start with your presentation, and then we can go ahead with Q&A. Thank you.
All right. Thank you, Prash. Nice to see some familiar names. I see Rashmi, previously a student.
It's so good to see you.
Hi. Same here. Robin is there and a few others. Thank you all for joining. Let me just share my slides. Okay. Okay, so can you see my screen?
Yeah, yes, please. Yeah.
Do you guys see my screen?
Yeah, yes, please, Asif. Yeah.
Okay. Okay, thank you, Prash, and thank you everyone for joining. Once again, apologies for that chaos a little earlier. I'm a Zoom person, and Google Meet has not been very kind to me. But eventually it works out. Anyway, good to be finally back and to be speaking with all of you. First of all, I just want to say, I think knowing this platform that has been established by Prash through Bioclues and the people who have come before me, I just don't feel I am, ready for this kind of an honor. But Prash insisted, so here I am, and but yeah, looking at people who have come before, I know they have done so much, and I've just done very little. And so I was just wondering, like, what to call this conversation and Sci'versation with Prash. So I titled it as a small reflection, or just as a reflection. So I'm going to use this opportunity as just a reflection of what I've done, and to share with all of you a bit of that, and hopefully there's something for you to take back with you from this conversation. So once again, thank you so much to Bioclues and Prash for this honor. So just to make sure that you are at the right talk, so this is what was advertised, and so if you're here because of this, then thank you for being here. So I called Prash yesterday just to understand what exactly do we talk about here. I've seen few other talks, and it seems like it's quite broad. It's quite a broad range of what people to share. So I was just wondering, there's just so much that we could share, and it was a bit difficult to decide. So as I titled it as a small reflection or a reflection, I'm just going to share my journey a little into bioinformatics, data science, and hopefully through that we could have some more specific conversations. All right, so I'm invited by Bioclues, and I'm originally from India, so my roots are in India, and it's always good to connect back and try to give back to the community in one way or the other. So I was born in India, and I grew up there. I was there for 8 years, and then I moved. Thanks to my father, I moved to Brunei, and I was in Brunei for 13 years. So a lot of my early schooling, primary school, secondary school, what do you call O levels, A levels, the British curriculum, the Cambridge curriculum, was all done in Brunei. So there was 13 years of my life there, and then I moved to Singapore. I spent 11 years there. This was mostly my completing my bachelor's, and then my master's, and then my PhD, all at the same university, which is National University of Singapore. They're doing a lot of wonderful work over there, and I'm really happy how things are shaping up over there. And I benefited a lot from the training that I got during my time in Singapore, and I got to meet a lot of wonderful people. And Rashmi was one of those people that I met there, and I think she's based in India now. But anyway, so then I completed my PhD, and I moved to the US, and I was with Johns Hopkins University in the US. It didn't last long. That's because I got selected by Johns Hopkins to be part of a big collaboration with Malaysia, Perdana University in Malaysia. So I was part of the pioneer team that was tasked to go to Malaysia to help set up to help set up this university over there. This was in 2011. So I went to Malaysia, and I ended up. I didn't think I would be there for 8 years. The plan was maybe 2 years, 3 years, but I ended up staying there for 8 years. So I was there growing this university called Perdana University, and then currently I am in Turkey. It's no longer 2 months. It's going to be this is a little old. It's supposed to be 12 months. So it's going to be 12 months. So yeah, almost a year. I actually came on 29th of December, so it's going to be exactly a year soon. So that was my journey around the world, and I'm not sure where I'm going to be next, but wherever I go, I want to make sure that I do as much as I can to spread the love of bioinformatics and data science to as many people as possible. And that's one of the key motivation in that journey when I discovered bioinformatics in Singapore. So so a lot of my actual work kind of started when I was in Malaysia with Perdana University and Johns Hopkins, because that's when a post PhD. So that's when I got the chance to do a lot of stuff. So over the years, I have done a few things. For example, I launched the Center for Bioinformatics. And I was the founding director of the Center for Bioinformatics, and then this was in 2014, and then in 2015 we got upgraded as a School of Data Sciences. I was the founding dean of the school, and along the way I was appointed as a Chief Data Officer. And also, while at Perdana University, I also founded a startup company, Alterco, which is focused on data science. Your data, our solution was our tagline. So these are all still there. Of course, I'm no longer at Perdana, but the school is there, managed by my colleague, Dr. Yam. The center is also part of the school. The data officer, well, somebody else is there, and I was the founding CEO of Alterco, and I've handed over to my colleague, Dr. Choi Si-Bing. Also, while doing all this, I was also actively involved in EpiBioNet. I actually was involved in EpiBioNet for a long time, if I'm not wrong, 2006 or 7, through one of the founders, Prof. Tan Tin Wee. It was a long journey. And at the moment, I'm the EXCO recently concluded, so I was the former president, and we will have our first meeting soon, and we will decide who's going to be the next president. So I had the opportunity to lead EpiBioNet as the president, having served in various roles before that over the last 15 years with EpiBioNet. And recently, since 2017, I got very active with Goblet. At the moment, I am one of the executive board members of Goblet. So I have an opportunity to also contribute and shape Goblet. And one of the things we did was to bring Goblet AGM to Asia for the first time last year through INCOP 2019 in Jakarta. MBIS is Association of Medical and Bioinformatics, Medical and Bioinformatics Singapore. So I was a former president. I'm currently the vice president of that. So I'm also happy to contribute back to Singapore. My BioInfonet is something we started, some sort of local node of EpiBioNet. You can think of it that way in Malaysia. So my Malaysian Bioinformatics Network, one of the founders there, and trying to grow bioinformatics in Malaysia. So these are some of the things I've done over the last few years. And currently I'm here in this beautiful institute, previously an old of some sort that has been restored, and it looks gorgeous, beautiful. So if any one of you has an opportunity to come to Istanbul after Corona, do let me know. We'll be happy to show you around. These are my bosses here at the moment, Prof. Doimaz and Dr. Sardar, director and deputy director, and this is Prof. Romeza, the rector, and these three individuals were responsible in bringing me over here. And of course, the connection that was made, this connection was possible again through Johns Hopkins. Johns Hopkins introduced me to them, and one thing led to another. But my main reason of being here again is to help grow bioinformatics at Bazmi Alim Waqaf University, specifically of course there, but broadly in Istanbul, and hopefully as wide as possible in Turkey. I'm also a recipient of this fellowship by TÜBİTAK, the funding agency in Turkey, Istanbul. So this also kind of enabled that moving over to Istanbul. So I'm funded by this, and this is a 3-year funding. And through this funding, I hope I can contribute to the country. So moving forward, a bit of a reflection. A lot of what I do kind of goes back to the training that I got from my former supervisors or my superiors in the past, and I want to kind of acknowledge them and how they have shaped me in many ways. And some of you may recognize these names. So Vladimir Bruzik was the first person who introduced bioinformatics to me. I did an internship with him during my undergrad final year, and that's how I really got to know about bioinformatics. And I've stayed on since then. So I am really grateful to the training that I got from Prof. Bruzik, and of course Prof. Tan Tinwi also was a key champion. He was my former PhD supervisor, and Prof. Thomas August. So these three individuals are my former PhD supervisors. But as I mentioned, Prof. Bruzik was one of the first, and then along the way, Prof. Tan Tinwi came into the picture, and later on, Prof. Thomas August came into the picture. Prof. Bruzik and Prof. Tan were in Singapore. Prof. Thomas August was actually one of the directors of Johns Hopkins Singapore. So that's how I got connected to Johns Hopkins, and so he was based in Singapore. He was basically shuttling between Hopkins and in the US and Singapore. So what did I learn mostly from? Of course, there's a lot of overlap in what I learned, but I remind myself. Notably, I think what I take away from each one of them is, for Vladimir Bruzik, is the value of education. The importance of good, high quality education. So that reminds me. He always kind of told me that I have to really catch up with others because I know others have had a better education, and I know I may have not had the similar opportunity. So there's more to catch up, and so I got to work hard in order to be able to catch up. And I'm still catching up. I hope. Yes, the importance of education remains, and I truly value that. And there were of course, so many more experiences that we don't have the time to share. With Prof. Tantinwi, I really learned the value of giving back to the community. He's so involved with community work. He founded one of the founders of EpiBionet, and so many other things that he has done, and I'm helping now carry that flag forward. So and do so much more for the community. So that's really thanks to the influence that Prof. Tan had on me. Prof. Thomas August. I would say the importance of research. Of course, everybody, the others also, had a lot of impression on me on research. But with Prof. August, I really learned a lot. He passed away recently. He was 91, if I'm not wrong. And even at that age, he was working like crazy. He was working so much more than everybody else. Was staying up late night. It's a big loss to the scientific community. But he had no experience in bioinformatics, and even at that age he was prepared to pick up bioinformatics, learn bioinformatics. We have published so much on bioinformatics with him. But what I take home with him is the importance of high quality research. So my notable experience that I would like to share with you all is that he's one person. There was just so much patience that I had to have, because he would go through these versions of the papers again and again until he was truly satisfied. Sometimes he would say, like, if you read it 1 week later, 2 weeks later, and if you don't feel there's anything wrong, that's when you know that it's ready to go out. Otherwise, you have to keep working on it. And I jokingly tell to my students and others that if I were to count the number of versions that I have had to work with him for some of our papers, they might go to the tune of 500 to 1,000. So imagine going through 1,000 revisions of all the documents, of the papers. So it's I wouldn't say he was a perfectionist, but he really wanted to nail home that a paper is only done when it's done. You've got to make sure that the audience is able to maximize from it. It's not about just finishing and getting it out. Make sure that the audience can really appreciate what you're doing. So you're not writing for yourself, but you're really writing for your audience. So learned a lot of patience, and sometimes now my students get frustrated because sometimes papers take longer than more 2 years, 3 years, and yeah, in a way I'm testing their patience, just like how I got this tested. But all for good reasons, not because I want to delay or anything, but really you want to be happy with whatever that goes out. Okay, now moving on, Charles Wiener was the dean that went with us from Hopkins to Malaysia with Perdana University. What I learned from him was the value of leadership. The kind of leader that I wanted to be. He was really open-minded. Really, his doors were always open. People could just walk in. He was so chill. They would listen to you. It was like more like a friend than really like a boss. And that's the kind of supervisor that I would like to be. When you compare yourself with others, even if they're younger, we are equal, we are peers, and the only difference might be I have more white hair than them because I'm older, I've lived longer, that's it. Otherwise, intellectually, we are on par, and we can, there's no such thing as that hierarchy between us, between those postgrad students, let's say. Right, so and I try to imbibe that and try to hold that with my students. So I try to keep my doors open. They can walk in and we can always have conversation. Whether it's positive, negative, we can talk about them and we'll try to move forward. All right, so that's a bit, not a bit, but briefly about my background. So moving forward, then I want to talk about, three aspects of my journey. I always believe that looking at what the training I got, I always believe that an academician, I consider myself as an academician. As an academician, there are three tenets, there are three pillars that I value a lot. And I think our journey is incomplete if we are not fully involved in those three tenets, three pillars. So a lot of us do research, and that's great. And I think besides research, we should also be involved in education, educating the young minds, and providing services or outreach to the community. So these are the three pillars: research, education, and services that I strongly believe in. And I think we should be doing all the three, maybe not in equal proportion, but we should be involved all the three, from time to time, in order to get more complete or holistic, aspect of being an academician and really contributing to the community. And this again is, you could see where that comes from. That comes from the training that I got. So now, before I move on to the three aspects, I just wanted to share this definition of bioinformatics. Everybody knows the first definition, which is the operational definition. The second definition, which I call the philosophical definition, kind of stayed with me. And I'm not sure how many of you are aware of this, but I love to share this one, my thought about bioinformatics. I mean, you hear bioinformatics as a tool, you hear all kinds of ways people describe bioinformatics, but this one kind of changes that perspective. It seems like it's so much more than just a tool. Some of you might disagree with that, but anyway, it's just that one of the definitions out there. Is a young field, so there are many ways to look at this, but so the definition states from Michael Liebman, bioinformatics is the study of information content and information flow in biological systems and processes. So, and that's really broad when you think about information content and information flow. I mean, you could say that that's almost like biology, studying the whole of biology, the word information. And this is like looking at biology from the lens of information theory, And information content could be, for example, our DNA, RNA, protein. Information flow is how communication happens. And I like to say that, in the year 2000, the human genome was, the human genome draft was announced, and it's 2020 now, and we still are very far away from really cracking some of these difficult problems, trying to understand biology. That's because the information flow is still a big mystery. We are, of course, learning a lot. We have learned a lot, but this is still a big question mark. And only when we truly know the information flow, then we will be able to really appreciate and understand what's going on in biology. So content is one piece of the puzzle. The other big piece of the puzzle is this flow, how they communicate with each other. So yeah, we may have all DNA, we may know all the RNA, DNA, and proteins, but we still do not know how they gel together. So, and doing bioinformatics is essentially trying to figure that out. And I hope more of us could see bioinformatics as something along that line, and given this generic definition, it kind of changes the perspective of what bioinformatics is all about. It's not just tools and databases. It's so much more than that. Okay, I don't want to dwell deeper in this. We could always have a separate conversation, but I just wanted to bring that. And of course, everybody knows the importance of bioinformatics, the explosion of bioinformatics careers. So this is, this is just to remind that there's so much opportunity, but a lot of people are missing out from this opportunity because they are going where the crowd is. So I can see, I mean, we all see people are signing up for biotech programs, people are signing up for so many other programs, the traditional programs or the programs that are so well established. But you always, don't see that many people lining up to sign for bioinformatics programs. It's always a pity, and I'll share my share of that later. But this is where the demand is, and I just hope, there's more realization about this demand, and more would actually shift towards this to kind of even out. And the demand and supply. The demand is there. I don't think the supply is met, despite all these articles and things that people are posting and highlighting the importance. We still don't see the supply. So hopefully, to the youngsters out there, you could spread that message and communicate that importance to others. I think the problem is really at the high school level. We really need to go to the high school level and communicate this importance. The high school curriculum and that realization at the early stages has not really transformed yet, although there are efforts that are being done to change that, but I think that it has to be at the root, and this could be the reason why we don't see that translated later on. I know in INVIX was recently concluded recently, and there were high school students that presented, and it was really impressive. I heard that they were able to hold themselves and do. I just hope more of that could happen, and congratulate Bioclues and INVIX for actually moving in that direction. And another thing is, like, we often, especially the younger ones, the ones who are early stage in learning bioinformatics, there's this this lack of realization that bioinformatics is essentially data science. They often do not make that connection. So yes, we are bioinformaticians, but we are in some sense data scientists for life science. And it's important to realize that the larger umbrella, because the beauty of that larger umbrella is that our skill sets are, what do you call that? Our skill sets are reusable. Whatever the tools, the techniques that we use in bioinformatics actually could be reused in the other domains, in the other fields, and that kind of opens up our mindset and opportunities that we want to explore. I have had colleagues who were doing bioinformatics and later on joined Siemens, that doesn't do much bioinformatics. So I have a colleague who's in Singapore now working for Siemens. I have had another colleague who joined an insurance company, and they were able to do that because the domain may be different, but the skill sets are essentially the same. And it takes you about 6 months to learn that domain. And initially, they will guide you, teach you, and after 6 months, you might be on your own. And and after some time, you might be an expert in that new domain too. So the domain expertise is a question mark. I mean, because there are just so many of those domains, but most of the other stuff is the same. And it's important to realize, raise awareness that we are essentially data scientists, and we got to relate to that and think at that level. And of course, the demand for this is just out of the world. And yeah, I don't want to talk so much more about this. And this is another thing, that I love to share, the data, the big data thing that we talk about. And, a few years ago, the data size for biology, if you put all together, was like 15 petabytes. And people were joking, saying that that's just too small. 15 petabytes is what these hadron collider people generate, on a yearly basis. And then there was this article that said that by 2025, that might change. Genomics alone might be generating about 40,000 petabytes. So genomics alone might be the biggest producer of the big data in the years to come. And if you expand that and you consider healthcare, it's just going to grow so much more. So, biology essentially is going to transform the field of big data and going to be one of the biggest producers of big data for people to mine. So there's just so much that needs to be done. We need a lot of people who can actually hack this, make sense of this mountain of data, tsunami of data. We need more and more people. And there was also a thing that I heard from my former supervisor, Prof. Tan, science at the speed of thought. Just like how we can go online and buy things, it might be one day that a lot of the wet lab that we do could be outsourced. You go online, there might be an Amazon version of science where you can just say this experiment, press buy, a few days later they send you the results. So if that happens, then what do we do? I mean, the need for all these labs, I'm not saying that they will disappear, but that's where it might be moving towards, because these guys are experts, these guys are going to do a better job, they do that on a regular basis, the results are going to be higher quality. And then, so what we as scientists would eventually might be doing is just mining the data, making sense of the data, playing with the data. So that might be the future that's coming, science at the speed of thought. And our lives have changed, and Corona has hastened all that. So we go to also see what are coming. And again, that highlights the need for training of the younger minds towards this direction. And again, just to highlight that the data science industries, there are just so many, and if these tool sets are reusable, then so in terms of job opportunities for people who are learning data science, it's just tremendous. Or even bioinformatics, just tremendous. They can easily move around these various sectors, industries. They can be very mobile. It's a unique opportunity. It's maybe even unprecedented. That these individuals can really move to different areas and contribute in many ways to the betterment of each one of these industries. So coming to myself now very quickly, and what are the kind of research that I've been doing. I do both basic and applied research, and we could sum it up in this sense that, of course, at the basic level, you do a lot of data warehousing and build tools and techniques and other things, and then you apply this to genetics, immunology, and later on, and at a higher level to vaccinology or therapeutics development. I would, just go a little deeper by covering these, and this is also in chronological order, going with what I had the chance to do in the past many years. I kind of started by building databases, so I had a lot of opportunity to build databases, think about how to basically deal in the problems with databases. How do you build a platform where you could resolve those problems, the problems of data heterogeneity, data reliability, and all the usual stuff. So I spent a lot of my early days looking at those issues. So one of the things that we do is build specialist databases. So I had the fortune to build a number of those. And then later on, I also was involved in venom informatics analysis, in particular snake toxins because of their pharmacological properties. But funding kind of was an issue over the years. So I in some sense left that field and moved on to others, but managed to publish few I think relevant papers in that area before moving. In fact, one of my most highly cited paper comes from that work that I did in that field. So then the next area that I managed to get exposure was immunoinformatics under Prof. Vladimir Bruzik, prediction of T-cell epitopes in learning approaches. We actually built a number of these. Multipred was one of them that I contributed in, and we also did a number of analyses of these. So there are a number of papers along those lines, modeling the immune system, trying to understand computationally how the immune system works, prediction of T-cell epitopes and things like that. Vaccine informatics, this is a natural extension of the immunoinformatics work, whereby once you have a better understanding of how the immune system works, how the immune system deals with the diversity of pathogens, how can you select immune targets or immune targets that could be used for vaccine design. And these would be immune targets that could overcome the diversity of the viral pathogen and be applicable at the human to the large human population. So so that was the next area, and I did this for a number of pathogens, in particular viruses. So so that's another area that I have done a lot of work, and I continue to be involved in that area. Chem informatics based drug design, I have not done much, but I was involved in few in the past. We published something, and recently it seems to be coming back, and I'm now more involved in this given the corona situation. There's a demand for this. We actually just concluded 2 studies on this, and we are doing some wet lab work to test out some of the peptides that we identified. I would say, the bulk of most of the work that I've done actually on viruses, and viruses are one of my favorite, organisms to study because the genome is relatively small, and so it's so much easier for us to do all kinds of interesting analysis on them. At the same time, though they are small, we also have abundance of data on viruses in the public databases. So you're kind of not dependent on wet lab so much. So you have so much available out there that a lot could be done right away. So you could say that every one of those immunoinformatics projects, vaccine, kind of linked to the viral informatics work. And at the viral work, we are mostly looking at diversity of a whole number of viruses, and recently I've started analyzing all viruses, not just few selected viruses. There are like 5 million sequences available there, and so we had some projects where we studied all of those. So we have some interesting publications coming out. I'm also actually building, as part of this funding from TÜBİTAK in Turkey, some sort of a platform that would allow us to study diversity in real time for all those viruses out there, spatially, temporally, and also spit out vaccine vaccine candidates, drug candidates, diagnostic candidates. That's our long-term goal that we are gearing towards, and we're very excited about it. Hopefully, we'll be able to conclude that and share it with you all. Along the way, also with our various collaborators, I have done some disease biomarker informatics work where we try to identify biomarkers related to certain diseases, in particular dengue, again viral related. So that was very briefly the research aspect that I'm involved in and that I'm doing. At the moment, we have like 27 different projects that are going concurrently. A lot of them, 8 or 9 of them, are on Corona, and so many others and few and many other aspects. And we are always looking forward to collaboration. So if any one of you are interested, we could always have that conversation. Education, very quickly, as I mentioned, research among the 3 pillars: research, education, services. I think research should be at the vanguard because we really want to be moving forward with the latest and the greatest. And but in order for people to do the latest and the greatest research, they need to be educated. Education is therefore a very important aspect of achieving that goal. So we must not neglect this, and we must make sure that people in our team, the younger minds, the younger generation has access to the best education out there, and so we can really do great research. So my experience with bioinformatics education, of course, there's the formal education and the informal education. With the formal, I was fortunate to actually design a number of programs. So, for example, the Bachelor of Computer Science, Data Science at Perdana University, and a whole number, a bunch of postgraduate programs, postgraduate diploma in bioinformatics, MSc in bioinformatics, by coursework, by research, and the PhD. So we actually, did the whole documentation. They just because these are part of OBE, outcome-based education framework. So you got to follow a bunch of rules, and there are qualification agencies that look into that. They accredit your program. So there's a lot of learning opportunity there. I enjoyed doing all that, and we managed to accredit all of these programs. And the latest entry is the MSc by Research, which is due for accreditation very soon. But what I'm just saying is that there's education is not just teaching, and there's so much more that is at the back of that. How do you plan a curriculum? How do you design a curriculum? How do you deliver? There's so much work that goes into making sure that we can get the best outcome of that. And of course, there's always a learning opportunity because sometimes you just do not know what's the best way, and you learn from within, you learn from outside, you benchmark with others. It's a continuous learning process, and the OBE framework allows provides for that opportunity to improve this curriculum along the way. And recently, there's a work done by Goblet and others where they are coming up with this mastery rubric, and it's really nice that we have this global effort where people are publishing what are the kind of elements that we need in order for these programs to be able to do and achieve the goal that we want to achieve. Really happy to see that being published, and recently we also got to know that ISCB is looking into endorsing these programs. So at least we now have international body that could look into our programs and try to evaluate it and then eventually endorse it if it meets the minimum standards put forth by them. So that's a welcome news. We didn't have them when we were designing this, but it's nice to see that this is happening. Of course, along the way, I also was involved in developing continuous learning, the so-called informal programs out there. So these are in the form of boot camps and many others that I will share. So this is still a learning process. What's the best way to educate? We have also published a few papers on this. But it's a continuous thing, and I think maybe in a nutshell, we should really learn from each other and benchmark with others to bring the latest and greatest to have the latest and greatest as part of our curriculum. In terms of services, a lot of this I've done, of course, through Perdana University itself. So we launched something called DSX Initiative, Data Science Exchange Initiative. And as part of this initiative, we have actually hold a whole host of options like boot camps, talks, workshops, internship, career gateway. We even launched our own conference, which was in its second year this year and concluded recently. Symposium, mentor, junior. So that was our effort to reach out to the younger minds at the age of 7 or 8. Some of these are still in the pipeline. We have not rolled out, but a number of them we have. So that was my involvement there to reach out to the community in Malaysia, and slowly, because of Corona, we are opening this up to the wider community around in the region and Asia Pacific. But a lot of other things that I'm doing is also with these international bodies like EpiBioNet, and we'll be having EpiBioNet talks coming up on December 15. I hope some of you would join that, and we have some other initiatives, interesting initiatives lined up. And we have created a registry of bioinformatics educators and researchers. If you're not part of that, you should sign up. Our website is down at the moment because we're upgrading, but when it does come up, do consider putting yourself so we can connect the region. We have a lot of plans which I presented recently at the INCOP 2020 AGM, and I hope we could, push in that. We managed to do a number of them, but still more work that needs to be done, and I hope we can do so much more for the community, especially the students. And one of the things was to set up a student council. So that's something brand new that we have not done before, and we would like to pursue in that direction to get more students involved. So the registry and other things that are planned. And through Goblet, so with Goblet, I think it's very timely that we also have, I'm also part of that Goblet community. So Goblet is actually, okay, what does Goblet do? It does so many things, but essentially Goblet is like, if you are a bioinformatics educator, the students have you to look up to help them grow and learn. But for the educators themselves, who is there to help them grow and learn? Because it's a continuous learning. Educators, so the trainers need also training. So Goblet was, if I'm not wrong, was built, conceived because of that idea that the trainers also need some sort of a training. So we have the trainer program and many other things. Of course, they're also there for the students, not just for the trainers, but that was one of the main motivation behind Goblet. So I'm happy to be part of that. I'm learning a lot from Goblet and trying to tie them up with EpiBioNet, and hopefully Bioclues could also tap into Goblets, the opportunities provided by Goblet. I think there's a lot that Goblet can do, and they're very young. If I'm not wrong, they're in the 6th year. So there's a lot that could be done, and they haven't reached out much. Although the name says Goblet, I think a lot of the activities have been in Europe side and the American side. There's so much more that needs to be done on Asia side or South America or Africa. Although at Africa they have H3A Bionet that's doing a lot. I think on Asian front that more can be done through Goblet, and I hope Bioclues would actually reach out to Goblet and see how Goblet could contribute to the Bioclues agenda, bioinformatics agenda in India. With MBIS, I've not done much, but also tried to revive MBIS. But Singapore is a unique place where bioinformatics is quite mature, so maybe there's not much that's needed there, but still, I think the younger generation, there's more that can be done. I'm going to rush up because of time. Similarly, for Malaysia, of course, for Malaysia, we are doing a lot. We also have this My Bioinfonet, so we're trying to connect all that effort through some sort of common platform that everybody can connect to, not just with Pradana, but from different universities can be connected to. So there's that My Bioinfonet. Also, along the way, we created just a kind of a hobby thing, a data science interest group, which started on WhatsApp and kind of busted the number of maximum number. So we moved to Telegram, and so we are on Telegram now, and 50+ people, and I would love for more like-minded people to come on board and join. As I said, bioinformatics essentially is data science. So we started off just with one group, and then there was a need for local versions of this because students were shy. There was a lot of local content that maybe was not relevant to the global, but it really was because a lot of students were intimidated by the global thing, and they were not keen. Whereas we see that there's more, participation, or they're more open to joining the local ones. So we have created some local versions of these, although the contents do overlap from time to time. This is just a hobby. It's just a fun place for people to share, connect, and get to know, pose problems. Nothing formal. So it's just along the way, and I'm really happy to see it grow. So DSI Global, these are you can just take a photo and go to the link and join. But we also launched Turkey, Malaysia, Indonesia, India, Nigeria, and Bangladesh, and hopefully in years to come we'll have so many more of these. Again, it's not a competition or anything. It's just hopefully people benefit. That's the ultimate goal, that they benefit and take home something from this. And I've seen some actual benefits. Some people, actually see opportunities that they would have not been aware through these channels, and that changes their, life trajectory. And so that's really heartening to know that some of these small efforts contribute in the long way. And I just want to end with this slide, which one of my favorite slides. That 20th century was the century for physics and atom bombs and all that. 21st century is really the century for biology, biotechnology, and this is where the bioinformaticians really have a golden opportunity to do so much in this area. I remember a quote that biology has enough problem to last the next 500 years. So that's a lot of centuries. So data everywhere. There's just so much that we can do. It's only those who are really, prepared to grab this opportunity and do something about it will reap the fruits of that labor. So I hope more of us can, heed to that call of trying to wrestle this data and try to, make sense of it and come up with some value of analyzing that data, and so we can make some important scientific discoveries and educate people and contribute back to the community to enrich the community as a whole. And the need is there, the demand is there, and hopefully this we will have enough supply to meet that need over time. And through that, hopefully we can do so much more. So that's it from my side. Sorry if I took so much more time than necessary. So that's all that I could think of as a quick reflection and sharing with all of you, and I hope that was of some benefit. Prash, back to you.
Oh, thank you so much, Asif. That was a fascinating talk, a wonderful gist of your journey, both the scientific and as well as the educative front. But I wonder, how do you guzzle this much energy, Asif? You seem to be answering my WhatsApp messages even in the midnight, Turkish time as well. You got a lot of energy,
No, I'm still trying to compete with you and match up to your energy. You are just too fast in responding. I'm still slow in responding. But yeah, it's not easy. It's not easy, especially moving to Turkey. One of the goal was to spend more time with family. So also balancing family with all this. It's a challenge. I don't know, but I think we can achieve so much more if we are more organized. I love to use these task managers. I've experimented with a ton of them over the years. My favorite one at the moment is ClickUp, and of course, email. I've experimented with a ton of these email clients, trying to find the best one that can make me more efficient. My latest one is this Superhuman. So I'm always experimenting with these kind of tools, and so dump the ideas there, then organize and try to strike off as much as possible. It's not easy. You always miss some. People are chasing you, and there's just so many priorities. I just do whatever I can, and so far, things happen, and I've got a lot of support. I've got a lot of people who are helping me. I'm really grateful to them. The team here in Istanbul, the team in Malaysia, and EpiBionet, Goblet, just so many Bioclues. You have helped so much. So there's just so many nice people around that I'm grateful to, and they really actually make that difference. So together, I think we can achieve so much more.
Yeah, this with these wonderful words, that speaks volumes about your, the wonderful passion you bestow, Asif. Thank you so much. I'm deeply honored. So moving first, towards the kind of research background. You have tremendously worked on epitope-based vaccines. So in the realm of this COVID times, where do you see these epitope-based vaccines, turning to?
That's an interesting one. So there's always this debate of traditional vaccines versus epitope-based vaccines. It reminds me of one of my conversation during one of the dengue conferences where I asked this person from Walter Reed, Army base where they do a research on dengue. Like, what are your thoughts about this? So you do have two school of thoughts. Some people strongly believe on the traditional approach because you get this strong response, and the epitope-based vaccines have this poor response. Which is, the immune system is not as strong, because when you throw in the whole virus, you have the innate immune system kicking in, and that helps the adaptive immune response to be much stronger. With the epitope-based vaccine, you just have a small peptide, and there are so many other issues like, the degradation of the peptide and delivery of the peptide. But what I'm saying, or what I could share is that, well, the traditional vaccine also has its problems. It has not been effective in helping us with HIV, in helping us with dengue. Although there is a vaccine for dengue, is not really the most effective one out there. And with flu, we always need to do this regular reformulation. So there is limitation to the traditional approach, and we do need to find new ways to solve this problem. And the new ways would, of course, have their own problems, but that should not stop us from exploring them further. We need to see how we can resolve those problems. So, for example, in terms of the immune response, you can do adjuvant, and you can use like LAM targeting, where you could actually target that peptide to where it should go so that the response is much stronger. So these are some of the strategies that could be utilized, could be used in order to address those problems. In terms of degradation, you could use a DNA form of that vaccine, right? So there's so much that can be done, that can be explored, and I'm really happy to see that the scientific community has not stopped from exploring and continue to find new ways to improve the efficacy of such vaccines. The belief is that the future of vaccine is very minimalist, that future vaccines would be based on these small segments, because they are much safer and they are more targeted. Because the problem with using the whole virus is, although it's very good in terms of immune response, you can't really control which epitope gets selected. And sometimes you have this problem of immunodominance. The diverse ones are more dominant than the conserved ones, so they get naturally selected. And so you have this immune escape that's going to be a continuous issue when a new virus comes in, because the diverse ones will be selected and the conserved ones won't be selected. So we kind of need to cherry pick these conserved ones and boost the immune response through adjuvants and other things, and then have that memory response form against these conserved epitopes, and then hopefully when infection happens, then our memories response can kick in and can recognize that pathogen, because the targets remain conserved, and hopefully we could beat that problem through that. So people are also looking into universal vaccines, where your target could be conserved across various subtypes. So there's a lot of excitement, there's a lot that's going on. And bioinformatics is helping through predictions. One big challenge for bioinformatics was that a lot of these predictions were mostly predicting HLA binding, although you were looking at TAP prediction, proteasome cleavage, and other things. But they kind of stopped at just evaluating, predict. Even if you integrate, ultimately you were just checking for binding to HLA. So whatever you had was essentially a HLA binder. What was missing is the T cell receptor component. And I've seen some recent work, 2019, where they actually are looking into this diversity of the T cell receptor. So that's really exciting how, if we can nail that T cell receptor part, then we will have that holistic picture of that ternary complex, where you have the HLA, the peptide, and the TCR. And if we can correct that and come up with really good predictions, then I think we will have something positive to look forward to. But yeah, so the problem with the HLA was, when you go to the lab, a lot of those predictions just didn't seem to be correct, and that's where the disappointment was. So it's an ongoing thing. I think both sides are doing what they have to do, and which is a good thing, that we should explore these in parallel, and hopefully these epitope-based vaccines would be able to showcase the promise that we're expecting from them. I hope that addressed.
Yeah, wonderful, Asif. Wonderfully inserted. Yeah. The very first 4 or 5 slides, of course, have been my favorites, Asif. In fact, your work with amazing, mentors, the founder of Internet, the co-founder of Internet, Tan Kin, you know, who has really, shaped the way, the data science really looks in, Asia Pacific regions at least. And you have wonderfully worked with, eminent scientists from Johns Hopkins and other people. And not only that, we really wanted to educational flora, back to Asian countries, through which you have started a wonderful collaboration with Perdana University and other stuff. So how difficult was it for you, to convince that Perdana University is this has got this aura countries. And this is where the Johns Hopkins University and Perdana University should really collaborate for data science at least.
So am I muted? No, okay. Yeah, so how difficult it was, that's a good question. Of course, it was not a walk in the park, so there were some difficulties there, but I must say I was really fortunate to have a strong support from Johns Hopkins. My former dean, Charlie Wiener, was very, very supportive, and he showcased that support all the way to the top management of Perdana University, all the way to the chairperson or the owner of the university itself, Tan Sri Mohan Swami, who has been very, very supportive of what we are doing. In terms of student numbers, it has been a struggle, because this is one of my other frustrations that I didn't touch upon. People say bioinformatics is so important. When you come up with all these programs, in terms of student numbers, you don't have the numbers there. It's like, okay, where are the students? I mean, when you talk to people, yes, it's very important, but when you offer the program, nobody signs up, or very few people sign up. And then you say, oh, maybe because the timing is not good. So, we moved from weekdays to weekends to nighttime. We have done all kinds of acrobatics to please the masses, to please the community, so that they could learn more from these. But the numbers have been a struggle. I do not know why. I'm still trying to figure out what could be the reason. Actually, there are multiples of reasons that could explain why that's the case, and we could have a separate conversation on that. So again, demand and supply. So despite these issues of not having the numbers, because of course the university needs to think about bottom line, needs to survive, needs their cost to manage, and we were not bringing in the student numbers. They always believed that this was the future. This is a very important area that we need to invest in. We need to bring in the talent. So they gave me the opportunity to hire people and to do all the things that I wanted to do with various education programs, services, and the research. So that really motivated to do as much as possible. So although there were challenges, at the same time, also positive forces that were much stronger than those challenges, and we just kept doing, and along the way, with the hope that some of that would cascade into something positive and would benefit some people, and that would come back and enrich us in one way or the other, or the community in one way or the other. So we just believed in hacking a problem and just doing, and not thinking so much about the negative aspects of all those. Whenever there were challenges, there were problems, we tried our best to be a problem solver rather than just delve into those challenges, and we've always found people who would support us and help us to overcome those. For example, we have, in a nutshell, we could say we have done like 300 to 400 events over the last 8 years. And that would have not been possible without the kind of support. And how many people really benefited from all that, that's a separate story. We hope as many benefited. And some of those activities, I think, in the long run helped increase the perception of bioinformatics or data science in the country. So overall, I think it's been good journey. It was positive. Yes, the challenges are always there. They will continue to be there. There are all kinds of challenges that are going to come. We got to stay positive. We got to look at the positive side and just chug along and hack as much as possible on those problems. And eventually the good will prevail, and as you build this ecosystem, it just becomes easier and easier to do the good things.
Yeah, wonderful, Asif. I mean, it's wonderfully insighted. So that leaves to me a slightly related question, Asif. I know these DSX talks, the AP Bennett talks, the Pedana Invest Initiative, educational talks, they have been absolutely well received. But to the fore, bioinformatics is slightly merging towards so-called data science. Data science has really been burgeoning over the last 3-4 years. But I feel, having been in India over the last 4 years, I feel that data science is still a kind of an emerging term in India. The so-called native bioinformaticists or the biologists are not really able to digest with this particular term. So with these educational courses that you have wonderfully initiated, how likely? I mean, I know that I'm absolutely in a positive oriented mode, that the students would really be inclined to these particular courses, and they would really make a merit out of it. But do you think that we in India are a bit behind, when at least when compared to the Southeast Asian countries, Asia or Singapore?
I think you would be better able to answer that. I mean, I'm not familiar with much of the development in India, so I don't think I'm the best person to answer this. It may not be fair for me to evaluate, given my lack of awareness of what's going on. I know a lot of what I know is from you and through a few others. But in terms of Southeast Asia, I could say that, barring few countries like Singapore, maybe to some extent Malaysia, many of the other countries are also struggling with the same issues. Bioinformatics, is not something that's fully there, and data science. Forget about. Maybe the thing is, like, in some cases data science seems to be more there because it's just more universal and it's relevant to a lot more areas, so you might see more of data science and less of bioinformatics. So that's one observation. They seem to be more data science ready than bioinformatics ready, but there are some countries where they're more bioinformatics ready than data science ready. And I just recall there was a paper that compared India and Malaysia in terms of bioinformatics. And the conclusion of that was, I think bioinformatics was much more developed in India than Malaysia. And I think for that window that they analyzed, I think that might be true. But recently, over the last, I think, many years, there has been a shift in Malaysia. So I think bioinformatics is gearing up and is catching up with India. But I think in India, bioinformatics is so much more developed. There's a lot going on. I hear a lot of stuff from what you guys are doing. But if you take Indonesia, for example, which I had an opportunity to do a lot of work with Indonesia. When we were working with them, there was only one institute in the whole country that had an undergraduate program. So that was really shocking for a country that big, with that big population. There was only one institute that had an undergraduate program, and that too, it was also only something recently that they started. So Indonesia would be maybe on that extreme where there's very little, but the efforts over the last 4 years we have seen a ramp up of that effort, and I really see a lot going on with a lot of activities. So the last 4 years, I think they've really picked up, and there are more conversations. So in a nutshell, if we are comparing India to Southeast Asia in terms of bioinformatics, I would say India is so much more ahead as a whole. There's a lot of good work going on. Of course, there's a lot of good work going on. Of course, we must remove Singapore from the equation. So India is really, I think, doing a lot there, but these countries are catching up too. There are some notable examples. I think Malaysia is doing okay, and Indonesia is picking up. I'm not so familiar. I think Thailand also has a fair bit of things going on. So it's there. but given the sheer size and population of India, I think there's so much more that's going on in India. In terms of data science, you might be right. I actually don't hear much about data science from India, but it could be my limited exposure to India. But at the same time, if you look at Southeast Asia, I think there's so much more buzz about data science in Southeast Asia, especially Malaysia, because it's IT and it's so broad, and there are a lot of retail companies and in the retail industries. So because of those, there's this drive to educate people in that. But it's really difficult to do a fair comparison, I must admit. Just based on my exposure, I would say maybe you have a point there. In terms of data science, maybe it's still behind. And compared to some of the countries in Southeast Asia, maybe not all of them. But I think for bioinformatics, India is doing a wonderful job. So much more that can be done, and I hope that they could also do something similar to data science. At the end of the day, data science is very related to bioinformatics, and if they've done a good job with bioinformatics, it shouldn't be difficult to expand and kind of generalize that as a data science. There's always this question that people ask me, there's just so many data science industries, like what would be the best industry to begin with? And I sometimes jokingly tell them that I think biology is the best, life science is the best one, because every other industry, you're kind of dealing with something that's created, it's man-made, whereas in biology, you're really creating, you're working with something that's not, well, if you believe in God and nature, it's not man-made. So it's much more fuzzy, much more complex. And if you can handle data science involving biology or life science, then there should be no problem with you managing the other industries, because those are man-made and should be much more simpler compared to dealing with life in general. So we are fortunate that we are dealing with one of the most complex domains of life science, of data science, and if we can manage this and have done a good job, then we should be able to easily move to the other industries and do a better job there. And so it shouldn't be that difficult for India to move and generalize into that direction. Again, there are a lot of caveats and limitations here, so that's just my observation.
Wonderful, Asif. I agree with you on that. Final few questions, Asif. I know your time is absolute. Asif, one of the prime aim of these Sci'versations is to ensure that the young brethren, take wonderful knowledge and learn, from these tutelages. I know, having worked with so many people across different countries, you might have disagreed in an agreeable way with your peers or with your supervisors or with your mentors or even with mentees, sometimes. So can you cite one example where you think of disagreeing in an agreeable way, or where you agree to disagree on certain aspects, and yes, and then reach consensus? Because nowadays the mentor-mentee relationships are a bit strange, especially in Indian conditions. The PhD mentors cannot probably say any word to his or her mentee, or possibly give an advice which is otherwise taken.
Yeah, that's you're putting me on a spot. So that's interesting. Of course, there are a lot of examples. When it comes to mentor-mentee, I think it's important that we give our mentees a good platform to grow, and I strongly believe in something that I learned from Prof. Tan, which is to give them as many opportunities as possible. So I know Prof. Tan was one of those guys who just throw these opportunities to us, and he also told us that you don't have to take them if you can't handle them, but at least grab those that you can grab. So I think the mentee needs to know that you have the best interests of the mentee, and that you are there to help them grow and do whatever is possible for their career growth and trajectory. So I think that trust element needs to be there, and when you have that trust element, then this openness comes in to, to be able to have these difficult conversations where you might disagree or they might disagree. And I actually encourage this, and I have no problem in apologizing to my students if I've done something wrong, because none of us is perfect, and we can make mistakes. So I believe in this flat structure where that hierarchy is not there, and like I said earlier, we are equal except that I might be older and probably seen more, that's all. Otherwise, intellectually, you might be better, and we can learn from each other, and you might have a something that I might disagree with, or I might have something that you disagree with. We can talk about this, we can debate about this, and yeah, agree to disagree. And I think we need to basically have this culture in the lab, culture in the team, where they can express whatever they have in their mind, but of course with respect. Do it properly. There's a way to do these kind of things. And so if we have that research culture in the lab, and people can openly discuss these things, then it becomes easier, to disagree with them without offending them, without affecting their motivation. And I have like one student in particular, when Corona came, we had a lot of disagreements, and eventually, like, well, the student realized that maybe some of our statements were not appropriate, not right, and that's completely fine. Sometimes they realize, sometimes they get too passionate and say something. I think we got to be patient. We got to let them express, and but I think the responsibility is on the mentor to be more patient, to allow them to express, and even if they might be wrong, not to go with them, harshly. Basically, apply wisdom. It's hard. But I think if the culture is there, people respect each other, then it becomes easy for us to criticize each other, and it's important that we can criticize. And with that trust, I think it just becomes easier to do this. And maybe I'll just leave you with this example that I learned. One of the things that I learned from the American culture was that we had colleagues from Johns Hopkins who came to Perdana, Steve and Dennis, and they were discussing a grant, and so much so that they started shouting at each other. and the best part, people around in the office got really worried. What's going on, and why are they shouting at each other? And few minutes later, during lunchtime, you see them going to lunch together, and hunky dory, everything is fine, as if nothing has happened. So that's the kind of professionalism we want, that when we are discussing science, we can openly criticize, and it should be kept to that, and then outside that box, it shouldn't affect our personal relationships, and we should be able to compartmentalize that and think of that as just a professional part. But being Asian, maybe, or from Asia, we sometimes get a bit sensitive with these things. It's not easy, it's much harder, but hopefully with more exposure. But again, I think the responsibility is on the mentor to have this culture in the lab, to openly talk about this, and it's okay for us to be wrong, and it's okay for us to apologize if necessary, of course. And I think that's how trust builds, and they know that they can count on you, that you have their best interests, and we can work together. Nobody's perfect. I mean, we or they are bound to make mistakes, and so I don't think we should see these mentors as people up there on the high horses who just cannot be wrong. So if that's the mentality, then I think it shouldn't be that difficult to agree to disagree.
Yeah, wonderful, wonderful, Asif. So Asif, I mean, as an AP Bionet president, I know you have really wonderfully shaped the way AP Bionet is into. You have really put a large focus into the wonderful legacy, that Professor Shobha, Professor Tang Chinvi, and all this, the first generation scientists have really put into AP Bionet. I have a very pertinent question. I mean, I need it to be a bit open here. But from Indian point of view, or from Asian point of view, I have a peculiar feeling that the ISCB has a different view on Asian countries, and probably that's one of the reasons why ISMB is never held in Asian countries. So, do you see that the intelligence systems in molecular biology conference or the ISCB aided conferences would come up someday in Asia? Do you see this? Do you think that that can really, because that would bring a lot of change probably at the way bioinformatics is taken up. I know APBanet is really doing a lot of things. I mean, we at Bioclues, we have been doing some kind of stuff. I think at the end of the day, we really need to bridge the gap and lock these horns. Yeah.
Thank you for that question. That's a very important question, actually. I must admit that I mean, we are an affiliate of ISCB, and I don't claim to know a lot about ISCB, although I think I know enough. And what I know is that ISCB, which has ISMB as the flagship conference, if I'm not wrong, has been mostly on the European side or the Western side. It has never come, but they have. I think they have discussed this. They have thought about this, and a solution they came up with this for this was to have something else called ISCB Asia. So it seems like ISCB Asia was the answer to ISMB coming to Asia, and we were actually one of the first to bring ISCB Asia to Asia through INCOP 2011 when I then moved to Malaysia. So that was the first time ICB Asia was held in Asia and in partnership with INCOP 2011, and we had joint meetings and all that. After that, they had few others, or one or two others, and then it, I think, went silent. And so it's like on and off thing. There have been some challenges in terms of partnering because they have certain requirements that need to be met in order to partner. But anyway, coming back, so maybe in one way, if you think about it, they have done it in not bringing ISMB, but maybe a version of ISMB called ICB Asia, and have it in Asia in partnership with the Asian conferences. So, but whether that really is the ultimate, in terms of convergence of intellects, so whether they would have an ISMB in the future that would be in Asia, I am not sure. I would be happy to ask them when I get to meet. This is a wonderful question. So, but yeah, why not? Why can't we have an ISMB? I don't. Why can't we have an ISMB in Asia? So I don't know. I don't have the answer, but in some sense they have done something towards that. So this is something they have thought about, and we do have ISCB Asia. Separately, we noticed that in Asia we have a lot of bioinformatics conferences. We are in some sense very fragmented. West. So we have APBC, we have GIW, we have INBIX, we have, of course, INCOB, and there might be a few other small conferences that are happening, nationally or regionally, internationally. And it will be really nice before we invite ISMB to bring ISCB to bring ISMB over here. We need to figure out how can we come together first. We need to organize ourselves first. And towards this, actually for many years now, if I'm not wrong, since 2014 or 2015, APBionet has been in conversation, has been teasing with the idea of a super conference. And we had the opportunity to speak to the Japanese authorities for this. I had the opportunity to fly over there to explore some of this. And then it kind of died down, and then we have revived it recently. And so, I mean, this is a continuous effort. We are gearing towards something called International Bioinformatics Congress for Asia, where we want to bring Bioclues in APBionet, GIW, or a few other notable players in the region, APBC and others, to come together so that we can maybe every 3 years have a Bioinformatics Congress, so we can really gather the masses, gather the community to one common convergence point, so we can really have this intellectual debates, conversations, and other exchanges that are much needed rather than be separated. So I think if we can achieve that, the plan is to achieve that by 2023. We have already spoken to GIW, they are on board. I think you representing Bioclues would naturally be on board with this. So I don't see a challenge there with partnering with you guys. We are thinking of speaking to Phoebe Chan of APBC. We are thinking of speaking to a few others from different organizations. And we have a calendar, lined up to make this happen. But we have given ourselves, at least 3 years, 2023, to make this happen. So there's a lot of time, and I hope we will be able to achieve this goal of the first International Bioinformatics Congress, where we really come together and showcase our strength as a community in Asia. Asia is big with a lot of people in there, and we should really do this. Once we have this, then maybe we have a compelling case to have ISMB be part of that in the future. But we have spoken to ISCB about this plan of converging this Congress. So, and ISCB has shown its support. They are very keen on this. But the plan there was to have ISCB Asia as part of that Congress, not ISMB. So if ISMB is equivalent to ISCB, which I don't think it is, then at least we will have ISCB Asia as part of the Congress in 2023. But moving forward, I really like this thing that you put up. This is a challenge, maybe personally for me, to hopefully, and maybe you one day, to have ISMB come to Asia, not ISCB Asia, but ISMB itself be in Asia, and maybe during one of those years when we do the Congress. So that might be the convergence point of two big conferences, the Congress in Asia and ISMB, and coming together. Hopefully that will happen maybe by 2026. So we give ourselves 6 years.
Yeah, wonderful, Asif. So one final question, Asif. How did COVID affect your research?
Surprisingly, this is the beauty of doing bioinformatics. It actually has not affected, but only increased the number of research projects that I have to do. So it's on the flip side. Instead of cutting, it has just increased. In fact, just on COVID alone, from no projects to 8 projects now that I'm involved in. So extra workload, extra things to do, but I'm not going to complain. And this is a good problem to have. Let's put it this way. Some problems are just good problems to have, and so yeah, it has not affected me because I do bioinformatics. I don't do wet labs, so I'm all right. And yeah.
I'm sure this is the best answer. The kind of positive vibrations that you can guzzle from Asif. This speaks volumes about Asif's passion about research. He says that COVID is certainly a kind of a blessing in disguise. It has given him more projects, more publications, more amount of work, and all those kind of things. And I'm sure the young audience over here, and if you watching the YouTube page as well, would agree that it's been the best Sci'versations that I've ever had over the last 15 occasions, and especially the kind of reflections that Asif has really taken us through his wonderful passionate research has been immensely helpful. And I always take a lot of inspiration and motivation from Asif, especially with the recent conference that I'm associated with with AP Bayonet and INCOG. The way that he has really driven the team, the way that he has really narrated down the wonderful picture is quite amazing. And I wish Asif glorious and wonderful years ahead. Both in science, education, and as well as all those kind of things. And may he be the Asia Pacific Bioinformatics Network, at least for the next decade. So that we need those young bees. We need someone who can really recognize organizations like Bioclues as well, and together we can foster wonderful science, passion, and research throughputs. For this wonderful time. Do you have any questions before we say goodbye or comments?
Thank you so much, Prash. You're very kind with your words. Thank you very much for your kind words and for all the support that you have given to me, to EpiBionet, and to some of my colleagues and friends. It's been wonderful working with you, and I really love what you're doing with Bioclues, and I am really happy to see the strong support that Bioclues has from the community, and I've seen a lot of things happening with in your WhatsApp group. I was always bombarded with messages, and there's so much going on, and I'm really happy the direction that you guys are shaping. So together, I think if we keep doing this, bioinformatics/data science will prevail, and hopefully more and more will benefit from this voluntary work that we are putting in, despite all our busy schedule, family commitments and other commitments. We still find time to do this. Hopefully, our family members would be kind to us, and yeah. So thank you, and I'm learning a lot from everyone. I have more to learn, and just want to thank everyone for all the love and the opportunity and the kind support that you guys have given. Thank you.
Thank you very much, Asif. So this is what Asif is, an amazing personality. And on behalf of Bioclues, in fact, we have Sundarda also here, our advisor and joint secretary Sundar. And everyone. I think there are a few. Anil, our the erstwhile Bioclues awardee, who visited Singapore. Thanks to the wonderful ORAC fellowship through which he has taken his wonderful research together.
Yes.
Yeah, and several people around here. On behalf of all of them, we would like to thank you for your time and energy today, Asif. Thank you so much.
Thank you, Prash. Thank you.
All so friends, that's it for today. So next week we are going to have Anil and Himakumari, wonderful scientist couple. So where we'll also learn the wonderful research that they have spearheaded 10 years ago with Professor Kaviteshwar sir. Thank you so much. Thank you, Asif. Thank you, Varindal. Bye-bye.
Thank you, Asif. Thank you so much.
Thank you, everyone. Bye.